Hey guys, welcome. Welcome to lesson 3 today. So I can see from the chat that some of you may have been on the earlier lesson, or it may have been younger siblings as well. So this lesson does get a little bit more tricky, a little bit more challenging. So let's just make sure that we are ready for it and we're totally focused on the maths that we're going to be discussing. Now, if you were on the previous lesson, I'm so sorry that I'm going to say the same thing again, but this is for anybody new joining us, and I can see there are lots of people here who were not on the earlier lesson. Just some news flashes for you to be aware of. From next week, we're only going to be doing the interactive lesson on Tuesdays and not Thursdays as well. We're very busy launching our app, and it does take a lot of time to set these lessons up and to share them and to plan all the work to go in with them. I really hope we can carry on doing them because I absolutely love being with you and learning with you and helping you and getting your feedback is absolutely amazing. It's so much fun for me. So we are going to just drop down to Tuesday, same times, 10, 11, 12, exactly the same times, but we'll just be live streaming on a Tuesday. But do check out social media and make sure your grown-ups are checking their emails carefully, because we are hoping to change platforms and go onto a new platform that will hopefully give us a bit more scope to be a bit more interactive and have some other tools available to us to make it a bit more fun and a bit more engaging for you. So, please watch those notifications carefully and the emails so that you're not sitting on YouTube waiting for us and we're somewhere else enjoying ourselves. Wouldn't want that. Also, next week we are launching a competition with a chance to win really good prizes, and I will give you more details about that on Tuesday. So that's just a news flash, just for you to be aware of some things that are changing. So as always, please do share these lessons with as many people so we can get as big a class as possible and support people who might just need a little bit of extra help with maths, love maths and just want to spend a bit more time, maybe not having enough work set from school, or just love learning and just want to be with other people, because it is quite a nice experience. We're all here together and it's very interactive. Okay, let's get ready for class, children. Rexy, are you ready? Yes, he is. Are you ready? Show me a thumbs up or one of your lovely emojis to show me that you are totally ready to focus on the maths. Let me see some nice emojis. What have we got here today? Let me have a little look. What emojis are going to come my way? Let me see them coming in. While they are coming in, I am going to drop the screen down for you to look at a problem that I set you at the end of the lesson. Oh, nice. Oh, some new ones come in today. Very nice. Thank you. Hello. So we set you these problems we set at the end of last week, at the end of last Tuesday. So if you did have a go, that'd be great. You're going to be straight in there. But if you didn't, have a little look. I'm going to drop the screen down. There's Rexy. He's sitting there watching. I'm going to drop the screen down just so that you can see this problem. While you're still sending me your emojis, let me see them come through. Ready to do maths. That's what I like to hear. And I have written this problem up on the screen so we can look at it as well. So a little brain teaser there for you, okay? So if 5 times 3 is 15, which it is, as we know, 5 3s are 15, 3 5s are 15, which number sentences would find the answer to 6 3s? Which of these would find the answer? Which of these would find the answer to 6 3s? Okay, put them in the chat for me or write them on your paper and then you can double check. I know that lots of our viewers just like to do their work on their own workstations and their own books, and they don't want to enter them into the chat, and that's absolutely fine because they can self-mark their work when we go through. Okay, so there's the question. I'm going to just bring you back up now so that you can see it on the screen. I've written it up behind as well. Okay, so if 5 times 3 is 15, which of these number sentences would calculate 6 times 3? Okay, if 5 times 3 is 15, which of these number sentences would calculate? Which of them would? Yeah, so 3 times 6, which, remember, multiplication is commutative. So 3 times 6 is the same as 6 times 3, isn't it? So there's 5 3s, that's 6 3s, and it's going to give us 18. So, yep, that one will. Anybody see another one that will? Anybody see another one? Yep, so we've got 5 3s and another 3. That's going to give us 6 threes altogether. That is also going to come to 18. Absolutely right. 5 threes plus 5. I can't see that up there. 5 threes plus 5 would give us 20. So that would not equal 18. Are there any others there? 15 plus 3. Yep, that's going to give 18 as well. Because we know that 5 threes are 15. So add another 3 gives us 18. Are there any others? Are there any others? So those do. They all give us the answer of 18. 5 threes plus 6. Well, that's 5 threes plus 2 more threes. So that's 7 threes, isn't it? So 5 threes plus 6 is going to take us to 21. So no. 15 plus 6. Well, again, that's going to equal 21. So no. So we just need to be careful. Sometimes people might see 6 threes and then go, oh, yeah, 6, 6. That's the answer. Well, it's not. So well done. Didn't catch any of you out. You were all totally on the ball. So that's fine. Now, the other question that I gave you, okay, I'm going to hold it up there so you can see the box. And then I have written it up. I'm going to read it to you. So while in Wonderland, Alice drank a potion and everything shrunk. And everything shrunk. Okay, so while in Wonderland, Alice drank a potion and everything shrunk. All the items around her became 10 times smaller. So are these measurements correct? I've written it up here for you. So while Alice was in Wonderland, everything shrunk by 10 times smaller. Everything became 10 times smaller. So let's have a look at this table and see what we've got. So this is the item, this is the original measurement, and this is after shrinking. Which parts of these tables are correct? And there's one missing bit as well. So the height of the door was 220 centimeters. It shrunk to get 10 times smaller. Is that the correct answer? If that shrunk to get 10 times smaller, what should the answer be? Can you answer in? The height of the door was 220 centimeters. If it got 10 times smaller, what should it have been? 220, 10 times smaller, what should it then measure? 220, 10 times smaller, what should it then measure? Exactly, it should measure 22 centimeters. Where has Alice gone wrong filling this in? She said it got 10 times smaller and it became 2,200. What mistake has she made? What mistake has Alice made? What's happened there? What has she done? To get 220 to 2,200, what has she done? Yes, exactly. Alice, you did 10 times bigger. So no. Your door is now 22 centimeters. Let's have a look at Alice. What happened to Alice? So her height, she was 160. And after she shrank, the table says she was 16. Is that correct? If she became 10 times smaller, is that correct? 160, 10 times smaller. What does it come to? Yes. So that bit is correct. So we've got the length of a book. The length of a book was 340 millimeters. When it shrank by 10 times, it became 43 millimeters. Is that correct? 340 divided by 10 becomes 43. Is that correct? Is that what happened to the book? Did it become? Quite right. What should the answer be? It is wrong. You're quite right. So what should the answer be? Exactly. 10 times smaller. No, not 43. Should be 34 millimeters. Okay. I think Alice ran out of steam by the time she wanted to put the last answer in. The height of a mug was 220 millimeters. After shrinking by 10 times, can you make sure you put the units of measure in for me as well, please? After shrinking by a factor of 10, 10 times smaller, How high is the mug now? Oh, nice units. Thank you very much. Makes Miss Nikki very happy when we see the units. Oh, thank you very much. 3.4 centimeters. Okay, so it is then 22 millimeters, or you could say 2.2 centimeters if you wanted to change the units. Yeah, so that goes to 22 millimeters, or it could say 2.2 centimeters. So thank you for helping Alice. A little bit of a warm up there. So let us just think and really make sure we've got this dividing and multiplying by factors of 10. Let's make sure we've got this really, really clear in our head. So when we multiply by 10, tell me what happens. Tell me. When we multiply by 10, tell me what happens to the number. When we multiply by 10, what happens to the number? Okay, show me your understanding. When we multiply by 10, what happens? Multiply by 10, what happens? Multiply by 10, what happens? It gets 10 times bigger. And what does that do to the number? When a number gets 10 times bigger, how can you tell? So do you mean if I multiply by that by 10, 2 used to look like that, and now it looks like that? Is that what you mean? It gets 10 times bigger? Is that what you mean? Tell me about it in terms of the place value columns. Tell me about it. Not 2 zeros, not for 10. You do not add 2 zeros for 10. It moves to the left 1 place, and then you add the placeholder 0 on the far right. So let's just have a look at the place value chart. I'm going to drop you down. Okay, you can say hello to Rexy on the way down. Okay, move 1 place to the left. Absolutely. 1 place to the left. So if I use my place value counters, and I have got here, we start off with a 1. 10 ones are 10. So we move 1 place to the left. But when I write that, if I multiply 1 by 10, I then add the 0 on the far right. So 1 now becomes 10. When I multiply 1 by 100, I take 2 jumps over. I take 2 jumps over. So when I do 100 times 1, that becomes 100. 2 placeholder zeros go in on the far right. 2 placeholders go in on the far right. When I multiply 1 by 1,000, show me 1 go into 1,000. Show me 1 go into 1,000. Show me in the chat 1 go into 1,000. 1 multiplied by 1,000. Show me. 3 places, exactly. So when I multiply 1 by 1,000, I take 3 jumps. So I'm going to the tens column, that's 1 jump. To the hundreds column is 2 jumps. To the thousand column, that's 3 jumps. So when I multiply 1 by 1,000, I have to put 3 placeholders on the right-hand side because I have taken 3 jumps across. Now, exactly the same thing is true of division. The number of jumps, but we jump the other way. So can you show me the division equation for 1,000 divided by 1,000, please? Can you show me the division equation for 1,000 divided by 1,000 and what the answer would be? Can you show me the division equation for 1,000 divided by 1,000? Can you write it in for me? Some people have put the answer straight away. I wanted the whole equation. Ooh, 1,000, not 100. What's the number of zeros, please? That's it. So if 1,000 is going to be shared amongst 1,000 people, they will all get 1 each. And just like when we made it 1,000 times bigger, we had to take 3 jumps to the left. When we make it 1,000 times smaller, sorry, I'm using the wrong counter. When we make it 1,000 times smaller, 1, 2, 3, and then we change it for a coin. 3 jumps to the right. Do we have to put 0 placeholders in there now? Do we have to put 0 placeholders in these? Do we have to put 0 placeholders in there? Why not? Why don't I have to write the placeholders in like I do when I'm multiplying? I don't have to put them in. I don't have to put them in because this is the largest column for whole numbers. So if I have 1 and there is nothing in there in the front, I don't have to put them in. When we go to decimals and we are going over to this side and we need to hold the place to let us know how much smaller we're getting, then it's different. But for whole numbers, we do not have to have the placeholders at the front. So let's have a little look at, let's take 3,000 and let's divide it by 1,000. Let's divide 3,000 by 1,000. Write the division equation for me. Let's write the division equation for me. 3,000 divided by 1,000. Now remember, it's going to take 3 jumps. So if I have 3,000 and I have to put 3,000 into 3 equal groups, I can think of it like that, or I can think about taking 3 jumps. Let's have a look. We're going to do it both ways. So 3 jumps, 1 jump, 2 jump, 3 jumps. We end up having 3 ones. So 3,000 divided by 1,000, the answer is 3. Okay. So if we have 3,000 and we have to divide them between 1,000 people, they would get 3 each. What about then, if that's the answer to that, what about then if I did 3,000 divided by 3? What would that be? What would 3,000 divided by 3 be? There's my 3,000. What would 3,000 divided by 3 be? So 3,000 divided by 1,000 gives 3 each. If we had 3,000 sweets and we had 1,000 people, they could each get 1 each. If we had 3,000 and we only had 3 people, okay, we're not making 1,000 times smaller. We're just making 3 groups out of the 1,000. They would get 1,000 each. So we're not making it 10 times or 100 or 1,000 times smaller. We're just sharing it amongst 3 people. Okay. Now, what's the corresponding multiplication equation to this? I think somebody may have already put it on there. Give me the 2 corresponding multiplication equations for both of those division equations. Let me see the inverse multiplication equations. Show them for me. I'm going to write them here. So 3,000 divided by 1,000 is 3. Okay, can you write them for me? Oh, well done. Okay, you done them? Now, 3,000 divided by 1,000 is 3, because 3 1,000s are 3,000. 3,000 divided by 3 is 1,000, because 1,000 times 3 is 3,000. Okay, we are looking at how those numbers go together. Really important, we are understanding how we move across on the place value counter. We get 10 times bigger, 100 times bigger, 1,000 times bigger. We are taking those jumps over. We are taking those jumps over. We are taking those jumps over. Okay, that's what's really, really important. Now let's see if you can use that place value knowledge to help you decide whether we are looking at equals, greater than, or less than. What are we looking at here? Equals, greater than, or less than. What are we looking here at? What are we looking here at? Are we looking at equals, greater than, or less than? What are we looking at? Equals, greater than, less than. Can I just say how amazingly well you are focused today? Absolutely brilliant, just like last lesson. Absolutely amazing. So when we are looking at 11 times 500, well, 10 times 500 is 5,000. So that's got to be 5,500. And over here, oh, well, just by looking, that's 11 times 500. That's 110 times 500. So that's got to be the bigger one, hasn't it? That's got to be the bigger one. So this is less than. This is less than. Yeah, absolutely right. Less than. Well done. Hey, great answers. Let's have a look at the next one then. Let's have a look at the next one. And I'll just block the top off, so it just makes it easier for you to focus. So 50 times 50, 5 times 5,000. And look at the number of zeros. So 5 times 50 is 250. 50 times it is going to add a 0 on. It's going to be 2,500. 5 times 5,000, well, just 2 times 5,000 is 10,000. So that's 25,000, and that is 2,500. Let's have a look. So this is less than again. Well done. This is less than again. It is less than again. Okay. To think about multiplying and using that place value. Let's have a look at this one. Okay. So we have got 90 times 600 and 600 times 9. Again, look at the zeros. Look at the number of zeros. We're dealing with bigger numbers on which side? So 90 times 600, is it bigger, equal, or smaller? Bigger, equal, or smaller than 600 times 9? Got one answer coming in. Let me see a few more answers, because then it gives me an idea of how you're managing. Yes. Look, 10 times 600 is 6,000. And then 9 6s are 54. So we're going to have 54,000 here. And we've got 5,400 here. So we are bigger. Bigger, bigger, bigger. We are bigger. This side is bigger. Well done. Let's have a look at the next one. What about this one? What about this one? 400 times 5, 4 times 500. 400 times 5. So when you look at the zeros, there's a similar number. So you're going to have to look at other factors. They're both in the hundreds. They're both one-digit numbers multiplying by three-digit numbers. So we have to look then at what the actual calculation is. If you are struggling with this, I really want you to join the earlier lessons next time, because I'm doing all the build-up work to this in the lessons that come before. So if you are struggling with this, please, please, please on Tuesday, join the earlier lesson. Don't worry about what age group it's for. The most important thing is that you are clear and that you understand the maths that you are doing. So please, 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 if there's anything that you are struggling with, please, please, please join the earlier lessons as well. And join us too on the third lesson. This means you're getting extra foundation, extra support. Well done. Well, they're the same, aren't they? 400, 5 lots of 400 is the same as 4 lots of 500. Yeah? Like 4 5s are 20, 5 4s are 20. Yeah? They both come into 2000 using your tables knowledge. What have we got down here? Is this our last one? What have we got down here? 400 lots of 9, 900 lots of 40. Let's look at the size of the number. Let's look at the size of the numbers we are dealing with. So we have a 3-digit number and a 1-digit number, a 3-digit number and a 2-digit number. Look at the size of the numbers you are dealing with. Look at the size of the numbers you are dealing with. Okay, look at the size of the numbers you are dealing with. Yes, 3-digit and 1, 3-digit and 2 digits. So we know this is going to be bigger. Okay, we've got bigger factors of 10 here. 3-digit number and a 2-digit number. 3-digit number and a 1-digit number. Okay, absolutely, that is less than. Well done. Brilliant thinking. Give yourselves a pat on the back, please. Give yourselves a pat on the back. Let's move those away. So we started, remember what I said, if anything at all is being a bit tricky, please join the earlier lessons. Please join the earlier lessons, because I go through things in a bit more detail and do a little bit more concrete work and build up. So that will help you, okay? So we started doing this. We started looking at this last week, but we did not get a chance to finish them. We started. So we already started looking at, if we are given the fact that 32 multiplied by 5 is 160, how can we use that fact to help us do these? And these are the ones that we have done so far. Okay, this is what we did. We said if we know that 32 times 5 is 160, we know that 160 shared by 5 is 32. That's the corresponding relationship. We know that 160 shared by 32 is 5. And we know that 5 32s are 160. Okay, we did those. We did those. Now let's have a look at one that we did not do. How could you use this fact to help you do that? How could you use this fact that 32 times 5 is 160? How could you use that fact? How could you use that fact to help you calculate this problem? How could you use that fact to help you calculate that problem? Okay. Okay. How could you use it? Using what you know already. Now I'm looking at the relationship between that and that. That's what I'm looking at. What is the relationship between 320 and 160? Okay, I'm looking there. Let's have a little look. So we know okay, I'm also looking at another relationship, which is going to be even more helpful. Have a little look. 32 times 5 is this. Okay, so this is the more helpful one. If 32 5s are this, what are 320 5s? What happened to this number? The same thing's got to happen to that number. That is increased by a factor of 10. So the answer will increase by a factor of 10. So those of you who said, will it be this? Yes, it will. That has increased by a factor of 10, so you know the answer is going to increase. You have to add another 0. Quite right. Let's have a little look here then. So knowing what we've got here, so let's have a look at this one. 1,600 divided by 5. What have we got over here that will help us? What have we got over here that will help us? We've done a divide by 5 somewhere else. So let's have a look at the relationship. Okay, so 160 divided by 5 is 32. Now we've got a number that's increased by a factor of 10. We've got 10 more 160s. So we will have 10 more groups of 5. We will have a factor of 10 more. Sorry. So we will have, the answer will be 320. Because that's increased by a factor of 10, so the answer will increase by a factor of 10. Let's have a look what else we've got here. Ooh, let's do this one down here. We haven't done this one down here. 50 times 32. 50 times 32. 50 times 32. Okay, 50 times 32. Look at what you've got above and use that to help you do 50 times 32. How is that going to help you do 50 times 32? Look at what we've got above. That's increasing by a factor of 10. That's exactly the same. So we're going to have 10 times as many. 10 times as many. The answer is going to increase by a factor of 10. Yeah. Let's have a look what we've got over here. What else have we not done? So, 1,600,000 divided by 320. Oh, now we're going to get our creative juices going. Thinking about our number factors. 1,600,000 divided by 320. Let me move across so that you can see other ones that we have done. 1,600,000 divided by 320. Divided by 320. Now let's have a look over here where we've done these divisions. We've done 160 divided by 32. It got us 5. So where are we on the zeros? Okay, where are we on the zeros? Well, we've added 1, 2, 3, 4 more zeros there, but we've added another 0 there. So how does it work out? 160 divided by 5, but actually it's divided by 32, but actually it's divided by 320. So how do the zeros work out? Let me see. Oh, I've got one answer. I've got one answer that is 2 answers that are correct. 2 answers that are correct. 2 answers that are correct. Well, do you know what? I would start off by saying, oh, let me take that 0 off and that 0 off. That's going to make things a bit easier for me. Let me just make them, balance them. That's 10 times smaller, that's 10 times smaller. That would help me. That would help me get my head around it. Then I would find it easier to say, okay, now it's by 32. So if 160 by 32 is 5, how many extra zeros have I got? 1, 2, 3. So I know I've got to add 3 extra zeros onto 5. So my answer is going to be 5,000. Okay, make it easier for yourself. What did you have over here? Okay, take a 0 off, take a 0 off. Then I know it's balanced. Then it makes it easier for me to manage that large amount. It makes it easier for me to manage that large amount. Okay, think about how you can make it easier for yourself. And let's finish off with a multiplication. 3,200 times 50. 3,200 times 50. Well, hey, we've got 32 times 50. So can't we just add the extra 2 on? Because it's by a factor of 100 bigger. So if the answer is there, I need to make that 100 times bigger. I add my 2 zeros on. I put a comma in there. 1,000 and 160,000. 160,000. Look at what you can use already to help you. And as I've said, if you are a little bit shaky on any of this, then please, please, please join my earlier lessons so that we can do some more work on that together. So that we can do some more work together. Now, one other thing I wanted us to look at. One other thing I wanted us to look at today is also how you can do multiplications and divisions in parts, okay? So, for example, if you had 7,200 and you had to divide by 200, the answer is 36. Let's see how we can break that down. So first of all, divide by the 100 and then divide by 2. So you're not trying to do all of that at the same time. Divide by the 100 and then divide by 2 to make it easier. Okay, has anybody ever done that before? We're doing fractions next week on Tuesday. Has anybody ever done that way before? Divide by the 100 and then divide by 2. So using that way of working, can you calculate for me, please? 3,600 divided by 200. 3,600 divided by 200. Okay, split it up into the 2 different parts. First of all, divide by 100 and then divide by 2. First of all, divide by 100 and then divide by 2. First of all, divide by 100 and then divide by 2. Shall I do this up on the big screen? Because I'm not seeing lots of lovely right answers coming in. So I'm going to do it up on the screen. And I think this may be something we need to do a little bit more work on as well. So let's come up. Okay, some people, I have not seen the answer come up correctly yet. So first of all, let's divide 3,600 by 100. Okay, 3,600 by 100. It's going to move 2 places to the right. Yeah, so 1, 2, we end up with 36. I can see some answers coming in now. Now we divide 36 by 2. Half of 36. Double what is 36? Double what is 36? Equals 18. Okay. What is the corresponding multiplication equation? What is the corresponding multiplication equation to check that we have got that correct? So it would be 18 times 200 equals 3,600. Yeah? And for that, I would do 2 18s, 36, and then multiply it by the hundreds, 3,600. So break things up into 2 parts. Let's just very quickly do another one of those. Very quickly, let's do another one. We'll do it on the screen, okay? What is 18,000 divided by 200? What is 18,000 divided by 200? So let's do the 100 first. Okay, we know that dividing is going to move 2 places to the right. It's going to get 100 times smaller. So 18,000 divided by 100, it's going to move 2 places over to the right. So I'm going to end up with 180. Then I now need, but it was 200, not 100. I now need to divide by 2. 2 watts make 180. 2 watts make 180. 2 watts make 180. Exactly. So the answer then is 90. Okay, the answer is 90. And we would double check by saying 90 times 200. What does that equal? 2 90s are 180. Increase 180 by a factor of 100. 2 jumps over to the left. 180 becomes 18,000. And there we have checked that they are the same. You can't see that down there. 18,000. Should have gone a bit higher. So let's think about using the maths we know to help us solve new problems, okay? So if we have to divide by 200, 300, do the 100 first, and then do the 1-digit number. The same thing for 3,000, 4,000. Do the 1,000 first, then do the 1-digit number. Break those into 2 smaller parts, okay? Breaking things up. Thank you for joining me today. Once again, you have been an amazing group, really focusing hard on your maths. Now remember the news I shared with you so that you don't miss joining us. Where are you gone? Newsflash, newsflash. Oh no, there's all our hard work. I've got to go right back to get it. There it is, and it's running away from me. There is our newsflash. 1 lesson next week. Well, 3 lessons, but only on Tuesdays. Please remember, if you are struggling with anything, please do join the earlier lessons. So 3 lessons on Tuesday, 10 o'clock, 11 o'clock, 12 o'clock. Some of these things we work on the earlier understanding in the earlier lessons. So if there's any part of this where you felt a bit wobbly, please do join the earlier lessons. We're changing platforms, so watch out for the notifications and the emails, and we're launching a competition next week. So make sure you join us on Tuesday to find out all about that. An amazing group. Again, give yourselves a huge pat on the back. Rexy's going to give you a wave and a big pat and a big high five. Ooh. Well done. Brilliant spending time with you. Okay. And I will see you on Tuesday. You take care. Have an amazing weekend. Okay. From Rexy and I, goodbye. Goodbye. Rexy's waving. And we will see you on Tuesday. Make sure you tell your friends to come and join us. Have a chat before the lesson starts so you can be brilliantly focused like you have today. Amazing. Take care. Stay safe. Bye.